Imagine you are building an application with several different services. One service manages users, another handles orders, another controls the shopping cart, and another processes payments. Now your clients, such as a website, mobile app, or another application, need to communicate with all of these services. Without an API gateway, the client connects directly to each service. A request for user information goes to the user service. A new purchase goes to the order service. Cart changes go to the cart service. And payment information goes directly to the payments service. At first, this may seem simple, but as your application grows, things become messy. The client needs to know the address of every service. Each service may need to implement its own authentication, logging, security checks, and rate limits. If one service moves or changes its API, every client may also need to be updated. This creates many connections and a lot of duplicated work. An API gateway solves this by becoming the single entry point for your application. Instead of talking directly to every backend service, clients send all their requests to the gateway. The gateway receives the request, examines it, and decides where it needs to go. A request for a user profile is routed to the user service. A checkout request may go to the order service. A cart update is sent to the cart service. And a payment request is routed to the payments service. But routing is only one part of the gateway's job. The gateway can first authenticate the caller by checking an API key, access token, or session. It can also apply rate limiting. For example, if one client suddenly sends thousands of requests, the gateway can slow down or reject some of them before they overwhelm the backend services. An API gateway can also perform aggregation. Suppose the client needs user details, an order summary, and payment status. Instead of making 3 separate requests, the client can make one request to the gateway. The gateway contacts the necessary services and combines their responses into one result. This makes the client simpler and reduces unnecessary network communication. The gateway can also handle logging, monitoring, caching, request transformations, and consistent error responses. So, the main idea is simple. Without an API gateway, clients must understand and communicate with many individual services. With an API gateway, clients communicate through one controlled entry point. The gateway authenticates requests, enforces limits, and routes each request to the correct destination. Of course, the gateway must be designed carefully. If there's only one gateway server, it could become a bottleneck or a single point of failure. In real systems, companies usually run multiple gateway instances behind a load balancer. An API gateway does not replace your backend services. It organizes and protects access to them. One entry point, many services, and a much cleaner system architecture.